All right, so let's get right into it. So this is about MonoLens. It's a small tool to view part of your screen in grayscale or in simulated color vision deficiency. Why did I make this? So reviewers were asking us, please make your plots visible in black and white print. Maybe you know this. So this was in our current HCB paper that we are about to publish, and I wanted to have a quick way of doing that. Yeah, so and the other thing is, if you ever do graphical interface design, you want to make sure that your color themes are friendly to people who have color vision deficiency. We actually had this case for the iMeaning-Jupyter interface. Yeah, so if you want to use MonoLens, it's easy. You can just pip install it, or if you are familiar with pipx, you can just pipx run it. It's written in pure Python. It uses Qt for the GUI part and NumPy and Numba for the numerical calculations. It works on OS X and Linux and perhaps even on Windows. In principle, it should work because all these things are platform independent, but it's untested. And it's easy to use and it's fun to use. So let's just play around with it a little bit. So it just creates a small, so I'm opening it now in the shell on another screen. So now you should also see this little thing that I can move on top of the slide, and then it turns everything into grayscale. And I put in here some macrolith plots, which are with the default colors, and it's quite interesting. So in black and white, you have problems discriminating the bottommost one from the top one, maybe. And you can also press tab and then go to, so this was grayscale mode, and now it's red weakness. So now you see that the second color and the third color are almost indistinguishable. And if you go to green weakness, then the uppermost colors are almost indistinguishable. So, yeah. So this is the point here to easily see that. You can also apply this here to these Ishtar plates. So in red weakness, you don't see the numbers anymore. All right, so that's all. I mean, that's all it does. Let's close it again. So since this is PyHab, I also want to give you a small look under the hood because this is interesting. So what MonoLens actually does, it makes screenshots to give you an illusion of a filter. It's not possible for an app to act really as a filter on your screen, because apps cannot read the pixels under themselves. Maybe that makes sense, right? So if you don't hack into the window manager, you cannot do that. And this is a normal app. So this only works for static content. I can actually show you how it fails easily. Let's run it again. So if I switch slides now, you will see it still has the old image here. So, but if I move it around a little bit, it updates, and now it works again. Yeah, so that's how it works. So as you move the lens around, the screenshot is updated. And this is actually quite a challenge to do in real time, because if you have a full HD device, as you probably have, and if you have a Retina device, it's even more pixels, then you have 8 to 20 megabytes, and that you want to have a certain number of frames per second. And yeah, if you color convert this in real time in Python, you will have a problem. It actually works if you use NumPy. And you use some simplified color conversion code that I took from another project, which is just basically vectorized adds and multiplies. So in all, this is an embarrassingly parallelizable problem, and it also profits from SEMD, which NumPy also uses already. But you can make it even faster when using Numba, as you see in the next slide. So unfortunately, PySide 6 does not have a NumPy interface, but this QImage supports the buffer protocol, so you can actually hack into the memory of the image and do all these nice things here. And here are two functions to do the color conversion. This is how it looks like. So it's basically this part here. And if you do it in NumPy, that's it. And if you do it in Numba, that's it. So you just, it's almost the same code. You make a little for loop here and apply the parallel option here. And then it works 20 times faster. yeah, this brings me to a conclusion already. So number rocks, that's one of the takeaways here. And if you have never thought about this, so color vision deficiency is actually not rare. So it's 8% of of European males. Females are less affected because they have two X chromosomes, and if it's only deficiencies only on one of them, they can compensate with the other one. So yeah, what does it mean? 8%. So that's 1 or 2 persons in an average seminar room of 30 people. So it's really something to take into account. It's easy to forget if you don't have this deficiency, but it's also easy to fix if you're willing to tools like this. Okay, I'm a little advertiser about my other projects. So NoLens is just a little tool, but I also have some more serious things like Boost Histogram, and we also have a Python WebDriver panel, and iMeet, PyMC, and recently I added this or worked on this resample library a lot, which implements bootstrapping. Okay, that's it. So how do I do this with questions now? Should I just read them out?
Yeah, do you want to check immediately on the slide, or shall I share it? It might be easier if you have the link. Do you have it?
I mean, I have it open, so I can just read off the question and then answer it.
Yeah, that is easier.
So the question is, how operating specific is this? So I mean, in theory, it's not operating system specific, because one of the great things about Qt is that it is abstracting over all these things. Someone said it's really cool. Thank you. But I mean, in practice, so I had to really try it out. And so I have two computers here at home, one Mac and one Linux system, and I had to try it on both of them. I mean, debugging graphical apps is really a pain, right? You have to just try it out. You cannot do this automatically, or at least I don't know how to. And I really noticed a lot of things where the abstractions were broken, and I had to really very carefully use the Qt API to really have this property that it's part of independent. So I mean, since it works on two systems, it might also work on Windows. So if you have Windows and you have Python installed there, give it a try and let me know whether it works. Could this be used the other way around, make it so that people with color deficiency can disentangle the colors? Yes. I mean, not this app, but in principle, this is possible. There are libraries which do exactly this. I mean, if you know how the deficiency works, you can enhance the colors in such a way that someone with this deficiency can still disentangle them. So here it was, this is not what this is doing. So is the window size flexible? Yes, you can. So I didn't show this, but you can make it larger. This is currently a little bit awkward. You have to use your arrow keys to make it larger and smaller. I want to also make it so that you can just drag it in the future, but that's currently not implemented. Okay, so can you limit the number of grayscales? Yeah, no. So right now it's just standard grayscale in RGB, so like 256 different levels. Can this be used as a library? No, right now it's not, but I mean, there are libraries which do this. So if you want to do this, Color Spacious is a very good library for this sort of thing. All right, I think that was all.